I've already explained to you the importance of compound interest if you want to become rich. Here, I want to explain the various rules and formulas, definitions regarding to this component. They are basically two types of exponents. One is called the exponential growth, and the other is called the exponential decay. The former one moves upward while the later one moves downward. Now you have to learn some definitions. Exponentials or powers are always written in the form that you can see in the diagram, that is x to the power n. X is called the base, and n is called the exponent or power. So 10 to the power 2, which is equal to 100. So here 10 was the base and 2 was the power. Next, you have to understand the rules of exponentials. It's like the ones that we discussed for addition, subtraction, multiplication, and division. Some of them are x to the power a into x to the power b is the same as x to the power a plus b. Then open brackets x to the power a close brackets to the power b is the same as x to the power a into b. Now the interesting part about the compound interest are the formulas. First, we have simple interest. The formula is I is equal to the principal into the rate of return and into the number of times or years. For example, if your principal in the bank is $1,000 and the interest rate given by the bank is 5%, then after a period of 3 years, the simple interest is equal to 1000 times 0.05 times 3, which is equal to 150. In this way, the amount that you'll get after 3 years is $1,150. Now, the compound interest formula is the interesting one. Basically, the formula says that the amount after a period t is equal to the principal, open brackets, 1 plus the rate of return, close the bracket, to the power of time. So using this formula and continuing on the above example, the compound interest is 1000 times 1.05 to the power 3. Mind you that we got 1.05 by adding 1 plus the 5% interest rate. The compound interest earlier was $150, but now it is $157.63. So the amount after 3 years will be $1,157.63. In this way, you can see that the compound interest is more than the simple interest. Next, we have the concept of the continuous compound interest, which is highest possible limit of compounding. The formula reads like the amount is equal to the principal times the exponential to the power of the rate and the time period. It rarely is used, so it's just good enough that you have heard the term. So that's it about compound interest, exponentials, and powers. At least you must know this much. Set theory, as I've already told you in the real life application, is very useful. But first, you must know the terminologies or definitions. I will just list the words that you should know in order to be well conversant in set theory. The set is the actual collection of the objects that contains the elements or members. Sometimes there is another collection within a bigger collection, and that's called the subset. Then it follows that the subset must also have a superset, meaning that it belongs to a bigger set. Then there is a concept of universal set that includes all the sets in the discussion. Some sets will be empty and they'll be called null sets also. The next part is the addition, subtraction type of operations between sets. So there is the intersection of sets where we find the common elements between two sets. There is the union of sets where we join all the elements from both or all the sets involved. There are the complements of sets, the difference of sets, the cardinality of sets, and so on, although they are not that important as the intersection and the union of sets. Some of the classifications include disjoint sets, equal sets, and so on. Whenever you talk about sets, you must remember the word Venn diagram, which shows sets as circles. In this way, as you can see in the diagram, there are various ways the sets combine with each other. The most common ones are the two sets and the three sets, but theoretically there could be unlimited sets. In this way, if you know this much about sets, then you're all set to go. You don't have to be a mathematical genius to do calculations in your mind. So first we need some definitions and concepts that will help us do the mental calculations. The first one is estimation. For example, you don't have to be accurate and you can just estimate saying 29 times 4 is almost equal to saying 30 times 4, which is much easier to calculate, and that turns out to be 120. Basically, it's just saying it's good enough. Then there is this concept of rounding figures. Instead of saying 3.14, we can round it to one single decimal point, or 3.1, or to 0 decimal point, which would be 3. However, if the number is 5.76, then by rounding off we'll have to go to the higher number of 5.77 to the 2 decimal points, or 5.8 to 1 decimal point. Then there are the other terms like approximation that we have just discussed, and the accuracy level or the precision level. So these are various terms you have to be familiar if you want to do mental calculations, and even if you want to use the calculator fast. Now let's discuss some strategies for mental mathematics and calculations. The first one is the breaking down of numbers. For example, you have to add 47 plus 28. That's a bit complicated, and you would have to go back to your class 4 manual mathematics, which is quite cumbersome. So break it down: 47 into 40 plus 7, then 28 into 20 plus 8. Then just to add the easier ones, tens, like 40 plus 20, which becomes 60. So now we have an approximate value, but not the exact accurate value. Then we add the remaining ones, 7 plus 8, which is equal to 15. Then that's the easy part. Add the 60 and the 15 and you get 75. That can be done easily in your mind. Another common mental calculation strategy is compensating. This is good when we have numbers that are near the next tens or hundreds. Let's say the number is 59 plus 34. Just round up 59 to 60 by adding 1. Remember that you added 1. Now it's much easier. 60 plus 34 is equal to 94. You remember you added 1, so subtract 1 to 94 and you have 93. Finally, we have the compatible strategy. You use that when you have to add many numbers, like 18 plus 23 plus 2 and plus 7. Now just look at the 4 numbers and you can easily see that 18 and 2 are quite easy and they are compatible. So 18 plus 2 is 20. Then 23 and 7 are also look compatible, so add them and you get 30. Now add 20 plus 30 and you get 50. In this way, you learned some very common tricks for mental calculation that don't require to be a mathematical prodigy. They will also help you not only in real life but even in your exams when you need to do some quick calculations without having to go into your calculator. Also, to give you much more confidence with numbers and numerical operations or mathematics.